Just confirm audio video. Kindly confirm audio video. So, a very good afternoon everyone. Myself Prateek Mishra and I welcome you all to the YouTube platform of IMS Gate Academy. Foundation course of environment is going on and I hope you are enjoying all the previous sessions that we have discussed. My dear students, again I will going to remind you all those sessions are the basics over which you will going to develop a heavy conceptual concepts of environmental engineering. Especially the concept that we have seen in the last class is a very important concept of disinfection. So I hope you might have seen that topic. Today we will going to see another very important area from where regularly questions are asked, that is biochemical oxygen demand. It is one of the wastewater quality parameter which is used to analyze the quality of wastewater. It is a part of your wastewater engineering, and again, if you are expecting a question from environmental engineering, especially a good quality question, it will be from the biochemical oxygen demand. So again, before I start this session, I quickly give you few of the announcements. First one is our Telegram group link is given in the description box. If you want to have the lecture PDFs, YouTube session details, if you want to have regular job notification updates, and if you want to enjoy the daily quizzes, you can join our Telegram group. Link is given in the description box. Next, my dear students, we at IMS Gate Academy, we provide you with 800 hours of live teaching with interaction with doubt solving. Along with that, we provide you with theory and exercise book. Especially in our exercise book, there are more than 4,000 practice questions well versed in level 1, level 2 and level 3. We provide you with the comprehensive GATE question bank containing 34 years of GATE questions which is solved in detail, explained in detail, along with the alternate solutions and video solutions, and we also provide the key points and the chapter overview in our GATE question bank. We provide you with 12 personalized one-to-one mentoring sessions, and IMS Gate Academy is the only institute in the country to personally monitor the progress of each of his student so that their student can perform excellently in the upcoming GATE examination. We provide you with India's largest test series comprising of 130 plus tests, is starting from the chapter test, subject test, multiple subject test, advanced subject test and the full length mock test with the video solution. If you want to book a counseling session, you can call into these two numbers. You may get Rahman sir and Chatra ma'am and you can speak to them. They will going to explain you all these features even in detail. So by these words, I would like to start my today's session. My dear, we have started by calculating the water demand, and for calculating the water demand, you need to know the population of the community. After calculating the water demand, you have identified different sources from where you have extracted this water so that this water can be supplied in the community. Before supplying this water into the community, you need to analyze the quality of water, which is analyzed using water quality parameters. And after analyzing the quality of water, you have given treatment to this water. Then by the means of distribution system, you have supplied this water to the community. Now this water has reached to each and every individual present in the community. After different domestic and industrial usages, now this water has been converted into wastewater. So first part of environment is the raw water engineering, where you have extracted the water from the source and you have supplied it to the community. Once this water is converted into wastewater by the different industrial and domestic use, this water is now converted into wastewater. The collection of this wastewater, transportation of this wastewater, quality check of this wastewater, and then treatment of this wastewater and finally disposing this wastewater back to the source is classified as wastewater engineering. So different components of wastewater engineering starts from, wastewater engineering starts from collection of the wastewater, then transportation of this wastewater, You need to transport this wastewater from your household to the sewage treatment plant. That is transportation of this wastewater. Then quality analysis of this wastewater. Quality analysis of this wastewater. And after analyzing the quality of the wastewater, you give treatment to wastewater. So treatment of sewage, that is wastewater. Treatment of sewage. And once this sewage is treated, it is disposed back to the source. So disposal of treated sewage. Disposal of treated sewage. This entire thing is classified as wastewater engineering. Now this wastewater is collected and transported by the use of sewerage system. Basically, you lay different sewers, you design the sewerage network, and by that means you collect this water and transport it to the sewage treatment plant. In the sewage treatment plant itself, first you analyze the quality of this wastewater and accordingly you treat this wastewater. So quality of this wastewater is analyzed using wastewater quality parameters. So today's topic of discussion is this: wastewater quality parameters. Wastewater quality parameters. Wastewater quality parameters, right? You remember we have seen the raw water quality parameters. In the same way, you have wastewater quality parameter. Using this wastewater quality parameter, you analyze the quality of wastewater. The wastewater quality parameters are almost same as we have read for raw water. Only few additional wastewater quality parameter we read here in wastewater engineering. Those additional wastewater quality parameter can be listed as follows. So first I will write down wastewater quality parameters are again of three types. Wastewater quality parameter are again of three types. Wastewater quality parameters. Wastewater quality parameters are again of three types. Physical wastewater quality parameter, physical, chemical wastewater quality parameter, and the biological wastewater quality parameter. Same as raw water. And the biological water quality parameter. Okay. Physical wastewater quality parameter includes the same wastewater quality parameter that you have read in raw water engineering. So physical wastewater quality parameter includes suspended solids, determination of suspended solids for wastewater is same as we have done for raw water. Then next is turbidity. Next physical wastewater quality parameter is turbidity. Again, determination, everything is same. Then you have color. Then you have taste and odor. Taste and odor. And last you have temperature. Their determination is same, right? Their determination is same. But obviously, we will not talk about the permissible limits. The permissible limits here will be different. It will be based on the quality of the source on which you will going to dispose this wastewater. Okay. So only permissible limits will going to change here. But the thing is, determination of all these physical wastewater quality parameter is same as we have read in raw water engineering. Now coming to chemical wastewater quality parameter, all the raw water chemical quality parameter that we have read is same for wastewater as well. So for wastewater, we start with dissolved solids, then we have alkalinity, then pH, then hardness, then chloride content, then fluoride content, then you have nitrogen content, then you have dissolved gases, and then you have metals. So these are the common chemical water quality parameter that we read for both raw water and wastewater. Now, apart from these chemical water quality parameter, there are some additional chemical quality parameter that we also read in wastewater engineering, right? Those additional wastewater chemical quality parameter includes, first one is chemical oxygen demand. The additional chemical water quality parameter that we read here is chemical oxygen demand, chemical oxygen demand. Then we have, this is known as COD, chemical oxygen demand. Next we have biochemical oxygen demand. Biochemical oxygen demand. Which is known as BOD. Next you have theoretical oxygen demand. Theoretical oxygen demand. This is known as THOD. Then you have total organic carbon. Total organic carbon. This is known as TOC. Then you have population equivalent. Then you have relative stability. So these are the additional wastewater quality parameter that you need to read. Apart from these, again the determination of these chemical water quality parameter is same as we have read in the raw water engineering. But again the permissible limits will be different. Now coming to the third segment, in biological water quality parameter, we only check for the pathogens. Pathogens are disease causing microorganisms, I have told you yesterday, right? So in biological wastewater quality parameter, we actually check how many pathogens are present. Pathogens are nothing but disease causing microorganisms. So you can just note this down. So these are disease causing microorganisms. So this is a complete chart of all the wastewater quality parameter that we read, right? And this will going to give you the clear idea what we actually want to read and what all parameters are important. Here I have written something in yellow. This column is a very important column regarding wastewater quality parameter. Because if the question has to be framed, definitely it will be framed from this segment, okay? Now coming to this biochemical oxygen demand, this is our topic for today. Now my dear student, you see this. Whenever we are talking about wastewater, so we are talking about municipal wastewater that is coming from the households, okay. We are not talking about industrial wastewater. Reason being, different industry will produce different category of wastewater, and based on the type of industry, the treatment process of wastewater will going to change. For example, the wastewater coming out from a dyeing industry and wastewater coming out from leather manufacturing industry will be different. So both these wastewater cannot be treated using the same process or the same mechanism. So the treatment given to the wastewater coming out from a dyeing industry will be different from the wastewater coming from the leather industry. So here in general we talk about the municipal wastewater, that is the wastewater which is coming out from the households. So by wastewater here we mean municipal wastewater. Wastewater here is, we mean municipal wastewater. Municipal wastewater. Wastewater. That is the wastewater which is coming out from the households. Wastewater which is coming out from the households. Now you see this. This is actually the feeling, right? This is actually the basics of how we approach the treatment of this wastewater. Now, if this wastewater is coming out from the households, the major impurity which is present in this wastewater will be organic in nature. Okay? Because whatever wastewater we produce, either we produce it from the washrooms or we produce it from the kitchens. Okay, and both of these areas has high amount of organic matter which will be discarded in the form of wastewater. So the wastewater which is coming out from the household has major impurity as organic matter. So this wastewater has major impurity as organic matter. Major impurity is organic in nature. Major impurity is organic in nature. Now this is the basis of treatment. Okay. The basic thought process of treating the wastewater is the process should be economical. We should not waste much money in treating the sewage. Nobody wants to do that. No municipal corporation wants to treat the sewage by using heavy techniques or very costly techniques. We want to be cheapest in the technique which will give us the better results and the most efficient result. Now the best way to treat this organic matter is to decompose it. Okay. And decomposing this organic matter by the use of microorganisms. Because if you decompose this organic matter by adding any oxidizing agent, that will be again a costly affair. But if you simply apply some microorganism over this organic matter will automatically going to decompose without any cost. So whatever wastewater is produced by the households contains organic matter as the major impurity. In order to remove this organic matter from the wastewater, we simply decompose this organic matter either in the presence of oxygen or in the absence of oxygen. So we simply apply some microorganism over this organic matter so that this organic matter can decompose. Okay. So the treatment that is given to municipal wastewater rotates or revolves around decomposing the organic matter either in the presence of oxygen or in the absence of oxygen. Okay. Now you see this. This organic matter which is present in the wastewater is of two types. Now I am talking specifically about the organic matter, right? The organic matter which is present in the municipal wastewater is of two types. Organic matter which is present in the municipal wastewater is of two types. Biodegradable organic matter, biodegradable organic matter, and non-biodegradable organic matter. And non-biodegradable organic matter, right? Biodegradable organic matter and non-biodegradable organic matter. Biodegradable organic matter are simple chain organic matter which can be decomposed easily. So these biodegradable organic matter are simple chain organic matter. These are simple chain organic matter which can be decomposed very easily. On the other hand, you have non-biodegradable organic matter which are complex chain organic matter which cannot be decomposed by microorganism. For decomposing this non-biodegradable organic matter, you need to add oxidizing agents artificially. You need to add some chemical reagents artificially. So these non-biodegradable organic matter is complex chain organic matter. These are complex chain organic matter. Okay. But in order to decompose both these types of organic matter, you require some oxygen. If you are giving if you are applying microorganism to the organic matter, again it will going to consume some oxygen to decompose this organic matter. Even if you are applying any oxidizing agent, again it will going to add oxygen to decompose this non-biodegradable organic matter. So whether it is a biodegradable or non-biodegradable organic matter, in order to decompose this, you need to have some oxygen, or you need some oxygen to decompose any type of organic matter. This oxygen can be either utilized by microorganism to carry out the decomposition, or this oxygen can be utilized by the chemical reagents to oxidize this non-biodegradable or complex chain organic matter. So the amount of oxygen required to decompose only biodegradable organic matter is termed as biochemical oxygen demand. Please listen to me very carefully. Don't have any confusion on this. What is chemical oxygen demand? The amount of oxygen required to decompose only biodegradable organic matter is termed as biochemical oxygen demand, or BOD. Biochemical oxygen demand, or BOD. What is BOD? BOD is the amount of oxygen required to decompose only biodegradable organic matter is termed as biochemical oxygen demand, or BOD. The total amount of oxygen required to decompose biodegradable and non-biodegradable organic matter is termed as chemical oxygen demand, or COD. The total amount of oxygen required to decompose both biodegradable and non-biodegradable organic matter is termed as COD. The amount of oxygen required to decompose both biodegradable and non-biodegradable organic matter is termed as chemical oxygen demand. Chemical oxygen demand, or COD. Chemical oxygen demand, or COD. I think this diagram gives you enough clarity. Organic matter is basically of two types: biodegradable and non-biodegradable organic matter. Biodegradable is a simple chain organic matter, whereas non-biodegradable is a complex chain organic matter. The amount of oxygen required to decompose only biodegradable organic matter is termed as biochemical oxygen demand. On the other hand, the total amount of oxygen required to decompose biodegradable and non-biodegradable organic matter is termed as chemical oxygen demand, or COD. Please note this down. So, biochemical oxygen demand. It is the amount of oxygen required it is the amount of oxygen required to decompose only biodegradable organic matter to decompose only biodegradable organic matter is termed as biochemical oxygen demand. Next is chemical oxygen demand, or COD. Chemical oxygen demand or COD. So chemical oxygen demand or COD is the total amount of oxygen required to decompose biodegradable and non-biodegradable organic matter present in the wastewater. It is the total amount of oxygen required. It is the total amount of oxygen required It is the total amount of oxygen required to decompose biodegradable and non-biodegradable organic matter. Okay. So these are the definitions of BOD and COD. One more clarity I want to give you. If I am talking about biodegradable organic matter, biodegradable organic matter will be decomposed by microorganisms. Biodegradable organic matter will be primarily decomposed by microorganisms, right? Whenever biodegradable organic matter is there, it will be decomposed by microorganisms. Decomposed by microorganisms, or if you feel like, you can also add chemical to decompose this biodegradable organic matter. So biodegradable organic matter can be decomposed by microorganisms or by oxidizing agents. Okay. But if I talk about non-biodegradable organic matter will only be decomposed by oxidizing agents. Non-biodegradable organic matter will only be decomposed by the oxidizing agents or chemicals. Microorganisms are not capable to decompose these types of organic matter. So it is decomposed by only by oxidizing agents. Okay. So whenever we are targeting a treatment which is designed around microorganisms, so in that treatment we will be only targeting the biodegradable organic matter. Okay. One more fact I would like to give you here. This is a kind of a thumb rule. Okay. If the ratio of biodegradable to total organic matter is more than 80%, then only we go with the treatment by microorganism. That is known as the biological treatment. Treating the wastewater by microorganism is known as the biological treatment. So again, you can write down one note point. If biodegradable or let it be, this is a part of your sewage that we will going to see tomorrow, right? When we will going to discuss about the trickling filter, that time I am going to tell you. Right now you just see this. So BOD is the total amount of oxygen required to decompose the biodegradable organic matter, whereas COD is the total amount of oxygen required to decompose both biodegradable and non-biodegradable organic matter. Now next topic of discussion is determination of this BOD, how we determine this BOD. So next is determination of BOD. Determination of BOD. So this is a very easy, simple process. Don't try to complicate it. Even I will going to tell you in very simple words. Just follow my steps, whatever I am saying, and this test will hit your mind very hard. Step 1. X ml of the wastewater, X ml of wastewater, X ml of wastewater, right? X ml of wastewater is mixed with Y ml of aerated water. Why we are doing this? Just give me 5 minutes. Y ml of aerated water. X ml of wastewater is mixed with Y ml of aerated water to form X plus Y ml of diluted sample. X plus Y ml of diluted sample. X plus Y ml of diluted sample. Okay. Now question comes, sir, why we are doing this? So you have this wastewater which is containing some organic matter. Now this wastewater does not have sufficient oxygen to carry out the decomposition of organic matter. That oxygen is supplied by the means of aerated water. This aerated water has abundant amount of oxygen. Now when you dilute this wastewater, this diluted sample has sufficient quantity of oxygen to carry out the decomposition of organic matter which is present over here. Okay. So you see this. This is my wastewater sample. This is my wastewater sample. This is X ml of wastewater sample. It is dirty, containing suspended solids, everything, right? It is dirty, it is containing suspended solids like this. I would like to show you something here. So this is dirty wastewater sample. I think this is clear to you, visible to you, right? Then you have mixed with the aerated water like this. This is my aerated water. This aerated water has sufficient amount of oxygen, right? So when you mix this aerated water with this wastewater, you will get the diluted sample like this. This is my diluted sample. This is my diluted sample. I think clearly you can utilize, means see that this darkness of this wastewater has reduced a bit. Now this diluted sample has sufficient amount of oxygen to carry out the decomposition of the organic matter which is present in this diluted sample. Okay. So what you did, step 1 is you have taken X ml, that is some known volume of wastewater, and you have mixed it with some Y ml of aerated water. Why I have written X and Y? Because this is known to us. This is totally dependent on the person who is performing the experiment. And this X and Y ml actually comes by experience, right? These are not any fixed quantities. That 10 ml of this sample has to be mixed with 30 ml of that sample. No, never. It comes from the experience. If your wastewater is highly concentrated, then it will require more amount of aerated water. Okay. If your wastewater is less concentrated, means it contains less amount of organic matter, then less amount of aerated water will be required to carry out the decomposition of this organic matter. So again I am telling you, this X and Y will be known to me, right? If I am performing the experiment, I will going to decide how much amount of X has to be mixed with Y ml of aerated water. So this is not fixed. It totally depends on the existing quality of wastewater, and this totally depends on the experience of the person who is performing the test. Now see from where we are standardizing the things. So this X ml of wastewater is mixed with Y ml of aerated water to form X plus Y ml of the diluted sample. So now first quantity that we will going to calculate is known as dilution ratio or dilution factor. So first quantity you will going to calculate is dilution ratio or dilution factor or dilution factor. Dilution ratio or dilution factor is the ratio of final volume of the diluted sample, final volume of the diluted sample, final volume of the diluted sample, final volume of the diluted sample. So what is the final volume of the diluted sample? It is X plus Y ml divided by the volume of original sample present in the diluted sample divided by the volume of original sample, volume of original sample, volume of original sample present in the diluted sample, present in the diluted sample. So what is the diluted volume? Diluted volume is X plus Y. This is the diluted volume divided by the volume of original sample present in the diluted sample is X ml. So X plus Y divided by X. So this will be my dilution ratio or dilution factor. Okay. So for determining the BOD, first thing that we did is we have mixed X ml of the wastewater in Y ml of the aerated water to get X plus Y ml of the diluted sample. Then we have calculated the dilution ratio, which is the ratio of final volume of the diluted sample divided by the volume of original sample present in the diluted sample. Okay, I think there is no confusion till here. Then what we do is we take 300 ml of this diluted sample, we take 300 ml of this diluted sample and we fill this in the BOD bottle. We fill this in the BOD bottle. We take 300 ml of the diluted sample and we fill this in the BOD bottle. So this is filled in the BOD bottle, right? If you ever been to environment lab, you might have seen this BOD bottle. It is different from the reagent bottle, right? The characteristic thing about BOD bottle is total volume of BOD bottle that can be filled is 300 ml. That is standard, that is fixed. From here onwards, we are standardizing the things, right? Before this point, it is totally on the experience of the person who is performing the test, how much dilution they need to do, that is totally comes from the experience. But once you have prepared the diluted sample, now you take 300 ml of this diluted sample and you fill this in the BOD bottle. So you have filled this 300 ml of the sample in the BOD bottle. I'll try to show you how this BOD bottle looks. It looks something like this. It is in the form of cylinder like this. With this thing. So it is like this. There is one knob at the top, then you have this collar, and then it goes like this. It is different from the reagent bottle, right? Reagent bottle is certainly conical at the neck, but BOD bottle is having a cylindrical neck like this, right? So this BOD bottle is having the total volume of 300 ml. That is fixed. It is standardized. Okay. Now, from where we have standardized this? We have standardized this using the codes which are given in AFA, American Society of Material Testing, ASTM. So you have this BOD bottle. So this BOD bottle has a standard 300 ml volume. And here you have filled the diluted sample, right? So there is one knob like this. Here you have filled 300 ml of the diluted sample, like this. Okay, now the thing is very simple. You take this diluted sample and you place it in an incubator. You take this diluted sample and you place this diluted sample in an incubator. Incubator at 20 degrees Celsius for 5 days. And before placing this sample in the incubator, here you measure the initial dissolved oxygen level of this diluted sample. So here only measure the initial dissolved oxygen level. Measure the initial dissolved oxygen level. DOI of the diluted sample. Here only you have measured the initial dissolved oxygen level of this diluted sample. After keeping this BOD bottle in an incubator for 5 days at 20 degrees Celsius, what will happen is, these microorganisms which are present in this diluted sample will consume oxygen and will oxidize the organic matter or will decompose the organic matter. Means the amount of organic matter which is getting decomposed is directly proportional to the amount of oxygen getting consumed. More oxygen consumed means more organic matter will be decomposed. So initially you have measured the initial dissolved oxygen level of this diluted sample. After keeping it in incubator for 5 days at 20 degrees Celsius, decomposition will take place and more amount of oxygen will be utilized. After 5 days, you take out this diluted sample from the incubator and again, this time you measure the diluted dissolved oxygen value again. You again take out this BOD bottle. So this is the BOD bottle that we have. This is after incubation. So after incubation, measure the dissolved oxygen level. Measure the dissolved oxygen level of dissolved oxygen level, that is DO final of the diluted sample. So simply you have to measure dissolved oxygen here and you have to measure dissolved oxygen here. This is known as DO final and this is known as DO initial. Again, I think I need to draw this diagram properly. So this is the thing. So how we determine the BOD is step 1 is you prepare the diluted sample, X ml of the wastewater is diluted with Y ml of the aerated water to get X plus Y ml of the diluted sample. Then you measure the dilution ratio. After measuring the dilution ratio, you determine the initial dissolved oxygen level of the diluted sample. Then this diluted sample is kept in an incubator for 5 days at 20 degrees Celsius. In these 5 days, oxygen which is present in this diluted sample will be utilized for decomposing the organic matter. More amount of oxygen which is utilized means more amount of organic matter has been decomposed. So after 5 days, again you take out this diluted sample and you measure the final dissolved oxygen level of this diluted sample. Two things you need to keep a check. First of all, this incubator should be in dark. I'll tell you the reason. This incubator should be kept in dark. I'll write here, incubator should be kept in dark. I'll tell you the reason for it. Should be kept in dark. This is the first point. This incubator should be kept in dark, right? As simple as that. Now, how many parameters I know? I know the initial dissolved oxygen level of this diluted sample, and after incubation, I know the final dissolved oxygen level of this diluted sample, and I know the dilution ratio. Then BOD 5 at 20 degrees Celsius. BOD 5 at 20 degrees Celsius. Why I am writing 5? Because 5 days of incubation. And this 20 degrees Celsius is the temperature of incubation. So BOD 5 at 20 degrees Celsius, this is equal to initial dissolved oxygen minus final dissolved oxygen. The difference in dissolved oxygen, that will going to tell us how much amount of oxygen is utilized to decompose the organic matter. So initial dissolved oxygen minus final dissolved oxygen multiplied by the dilution ratio or dilution factor, multiplied by the dilution factor or dilution ratio. This is termed as BOD 5 at 20 degrees Celsius. So this is BOD 5 at 20 degrees Celsius. This is BOD 5 at 20 degrees Celsius. DO initial minus DO final multiplied by the dilution factor. So this is how you need to calculate the BOD. Okay. Now first point, why I want to keep this incubator in dark? Reason is, if you keep this incubator under the action of sunlight, then what can happen is, the sunlight will come in contact with this organic matter, and this organic matter may undergo the process of photosynthesis that releases oxygen in this diluted sample. And if the oxygen is released in the diluted sample, then this DO final that we will get will be more than actual. right? And when we'll getting this DO final as more than actual, then we will going to report this organic matter present less than actual. Again, if this incubator is kept in sunlight, then there can be a phenomena that can take place. The organic matter that is present in this diluted sample will undergo photosynthesis that releases oxygen. And if oxygen is released in this diluted sample, then this DO final is reported as more than actual. If DO final is reported as more than actual, then the BOD calculated will be less than actual, and that can severely damage the treatment mechanism, right? So you can write here, incubator is placed in dark, or you write like this, if the incubator is kept in contact of sunlight, then there is a possibility that organic matter present in the diluted sample can undergo photosynthesis which results in release of oxygen. In such case, DO final is reported more than actual. In such case, DO final is reported as more than actual. And if DO final is reported as more than actual, then BOD 5 calculated will be less than actual. You can see here, if this BOD final is reported more than actual, then BOD 5 will be calculated less than actual. Then BOD 5 will be calculated as less than actual. And if BOD 5 calculated is less than actual, then it will going to severely affect the treatment technique. Okay. For example, if in your wastewater 30 milligram per liter of organic matter is present and you are reporting only 25 milligram per liter of organic matter, then your entire treatment will be designed with respect to 25 milligram, right? And in that case, you are actually ignoring that extra 5 milligram per liter of organic matter. So you need to design the treatment technique for 30, but instead you are designing it for 25, and that can severely affect your treatment, because most of this organic matter will be taken out from the sewage treatment plant untreated. So that is why for testing this BOD, we keep this incubator in the dark so that the organic matter cannot come under the action of sunlight, because there is a possibility that this organic matter can undergo photosynthesis and that releases oxygen. This is point number 1. Point number 2 is, whenever this DO final will come out as 0, in that case you will never going to report the BOD. Reason is, first I will write this. If DO final comes out as 0, if DO final comes out as 0, then in this case BOD is not repeated. Then in this case BOD is not reported. BOD is not reported. BOD is not reported. Now you see what happens. This is X ml of your wastewater. X ml of wastewater. It is mixed with Y ml of aerated water. This aerated water is mixed in wastewater in order to provide sufficient quantity of oxygen to form X plus Y ml of diluted sample. Okay. Now what happened is, whatever oxygen that you have supplied by means of aerated water, there is a possibility that this entire oxygen have been utilized before 5 days. Means, if there is some organic matter which is present here, it has utilized all the oxygen that you have supplied using aerated water after 3 days. And still for 2 days, there was no oxygen available to carry out further decomposition. Right? So actually your decomposition has to be carried out for entire 5 days. But here what happened is, your decomposition stopped just after 3 days. So if there would have been more oxygen, then there would have been more decomposition that have taken place in upcoming 2 days. Right? So in this case, what we do is, if DO final comes out as 0, first of all we don't report the BOD. What we do in this case? We increase this amount of aerated water. Now this X ml of wastewater, is mixed with Y1 ml of aerated water. This X ml of wastewater is mixed with Y1 ml of aerated water, and Y1 is more than Y. This increasing the quantity of aerated water simply means we are increasing the amount of oxygen that can carry out the decomposition for next 5 days. So you increase the dilution of the wastewater if your DO final comes out as 0. Whenever your DO final comes out as 0, you never report the BOD in that case. Else what you do, you increase the dilution of the wastewater and then you again perform the test. So BOD is not repeated. Dilution of the wastewater is increased. Dilution of the wastewater is increased. Dilution of the wastewater is increased. And test is repeated. And test is repeated. Okay. So this is the case that we have. So this is the entire thing about your biochemical oxygen demand. I hope you might have understood this biochemical oxygen demand and all the things that we have discussed. After this, we have one complicated discussion of like kinetics of organic matter which is present. Then we talk about the 2 stages of BOD, and then we see the different relations, right? So again, it's a huge discussion. So this is the basic topic of biochemical oxygen demand. First you understand this properly, then only you can develop your concept to understand those complicated things, right? I hope you have learnt a lot today. You have got the basic of how we are calculating biochemical oxygen demand and how many types of organic matter are there. I hope you have enjoyed the session. Before moving ahead, I would like to again make few announcements. The first announcement is related to a Telegram group, my dear students. If you want to have the lecture PDF, you can join the Telegram group. The link is given in the description box. All the important job notification updates and the seminar and webinar link will be provided to you in the Telegram group. Along with that, we regularly post the quizzes. Next thing, my dear students, we at IMS Gate Academy will provide you with 800 hours of live classes along with interaction and doubt solving. We provide you with theory and exercise book containing 4000 practice questions. Along with that, we provide you with the GATE question bank containing 34 years of GATE question, in which detailed solution, alternate solution, video solution along with key points and chapter overview is present. We provide you with 12 personalized one-to-one mentoring sessions. Along with that, we provide you with the test series containing 130 plus tests. If you want to book the counseling session, you can call to these numbers. You can speak to Chaitra ma'am or Rahman sir and they can guide you properly. Even if you want to speak to our mentor, again you can connect with these numbers. Whatever basics we have discussed today, if you want to enjoy full-fledged concepts, you can join our online program, hybrid program, offline program that we provide at IMS Gate Academy. I hope you have learned this concept properly and I can expect that you will going to even revise this concept. If you want to have this lecture PDF, it will be provided in the Telegram group, so you can join our Telegram group. So this is all what I have to offer for today. Thank you so much for listening patiently. I wish you a great day ahead. Thank you so much.